Hi everyone. My name is Diana. I will be the host of this day one live Q&A session. So thank you speakers for all the great talks. We're super excited to have you here for our live session. So attendees, you're welcome to submit your questions for our speakers using the Q&A and the chat box on the AtScale conference website. So for now, we'll go into our first question for Ishan. So Ishan, can you tell us more about the video generation model, which produces consistent and coherent motion patterns, such as running, logging, or swimming? Tell us more about that, and how does it achieve this level of realism? Because that looks incredible.
So thank you, Diana. Thank you, organizers, for having me. This is a great question, and I think it sort of goes down to the design decisions that we made for Movie Chan. One of the key design decisions is the fact that we're generating videos at native frame rate. So we're generating videos at 24 frames per second, which means that for a bunch of these actions which require you to have high fidelity and high frequency motion being generated, we can generate that at native frame rate. This is a big departure from our previous work, like Make a Video or Emu Video, where we were generating videos at 4 frames per second. And so you would actually see temporal aliasing, and these types of actions would not really come well.
That's awesome. That's so impressive. And so we've seen some really, really awesome video generations on the website. But is there some sort of dedicated platform or repo where we can see more of those examples to understand more about the model's capabilities?
Yeah, so to enable this and also enable future benchmarking, we released about more than 1,000 generations online. So on our GitHub repo, and these are not cherry picked. So these are 1,000 evaluation prompts that we use to benchmark against competitor models. And so you can basically get a sense for the average quality being generated by our model.
That's great. Awesome. Cool. And then, so you mentioned also using Llama model for captioning the generated video. Like, what is your motivation behind that decision, and how does that model actually contribute to the overall quality and coherence of the captions?
Yeah, so the Llama model is, I would say, a pretty core ingredient of like getting our training data at scale, because videos typically don't have a lot of nice captions associated with them. And what we found is that we really need very high quality detailed captions to get the generations working. So imagine like a 8 second clip. You would really want the caption that you will have to describe the subject, to summarize the action in the video, to describe the interactions, all of these things. And once you have that coherent description, then you can feed that to the generative model to ask it to generate all the pixels that are present in the 8 second video. And so Llama video recognition model was pretty critical in us getting those detailed descriptions at scale, because we found that other models were not super good at generating detailed captions.
That's awesome. Yeah, that's very interesting to learn. So my next question is for Corbyn. I wanted to sort of get into what safeguards and technical limitations do we currently have to prevent someone from creating an AI twin that sort of like impersonates and represents another individual? How can this type of like privacy risks be mitigated?
Yeah, thank you for the question, Diana. It's a really good one and one that we think a lot about here. So if what you can see in the product today, we actually require anyone who uploads an AI twin to read a script. And this is a script that has to be recorded live, so you have to record in the app itself. And then we verify that the script kind of match like what is set, what you said in the video matches the script that's provided. And so through that, we can make sure that the video uploaded is done by the person using the app. And we also like moderate this and make sure that like there's no abuse happening as well to make sure the system is staying solid.
That's awesome. Yeah, I feel safer already. Cool. So then my next question is, how does the LibDub model handle input videos of like various length? Some are maybe shorter and some are longer. So what are some of the challenges with that and maybe limitations? Yeah.
Yeah, it's an interesting dynamic that we always struggle with and try to fix both sides or work on both sides of. So the model itself can actually uh, work with as short as 2 seconds of video, and we can actually produce like accurate lip syncs from that 2 seconds of video. With that said, more video, more representation of how you speak will always be helpful. But we can produce something that's pretty accurate as short as 2 seconds. I think the interesting thing is we do basically reuse video from what you upload, and so by uploading a longer video, we have more opportunity to use different parts of the video to make to help how the content looks and feels. So it's better to go longer, but we can go as short as 2 seconds.
That's very cool. Okay, I gotta remember myself to make a longer video then. Cool. So for it to look more like me, right? That's awesome. Another question for you, Corbyn. It came from a live attendee. So is this sort of AI-powered content moderation system currently used? Where is it currently deployed? Would you want to sort of talk a little bit about that?
Yeah, I saw the question. And it's a really good one. I also in the question it was implied that this person is also using captions, which got me very excited. So thank you for using our product. I hope you're enjoying it. So the content moderation system is deployed, the one that I presented today. And so I would actually love to I would love to see the reports that you're hearing, because if there's a concern of false negatives, that is something that should be flagged as a not as out of our terms and conditions, that you're still making videos with it. I would love to know. We try to be pretty conservative on that front. So I would love to hear what those reports are. On the other side, which is what we get more often, that we're being too conservative with what we flag as breaking our terms and conditions. That's feedback that we are still getting. The content moderation LLM org that I presented is doing a better job than it used to do, but we know it can do better, and we are actively looking at improving that system, potentially using actual people if needed.
That's awesome. Cool. And then so kind of following up on that, right? If an influencer has to use it beyond stories, like showing off some sort of product, is that possible?
Yeah, totally possible. We actually have a streamlined flow just for that experience. It's called AI Ads. You're welcome to use it, but you basically can start with a product URL, like you're going to your product page, and we'll pull the media from that page. We'll auto generate a description, create some different types of ad hooks, and ad scripts for the creator to read. And as long as the product is within our terms and conditions, we will be able to generate that video. It's actually a very popular initial experience to kind of help with performance marketing, and also have a global reach with your ads as well.
Fantastic. Awesome. Cool. Okay, so moving on to our next speaker, Sravan. Do you envision a future where machine translations will actually become indistinguishable from their original counterparts? If so, what kind of advancement do you think in NLP and machine learning would be necessary to get to this level of accuracy?
Thanks, Diana. That's a great question. So first of all, the machine translations has been used for quite some time in various products, right? Like for captions and whatnot. And the accuracy was pretty good overall. The challenges with audio being synced with video is around how do we make sure that all the speech characteristics of the speaker is captured well from the source language and transferred to the destination language or target language. From the accuracy perspective, I think we are actually pretty close on accuracy, and this was validated with both blue scores, which measures the accuracy, as well as human ratings as well. And if you listen to some of the translations generated by the models that we are using currently in alpha test and whatnot, you actually can distinguish between what is machine translated versus what the speaker is, especially if you are doing blind test and you have never heard the original speaker, which is the case for most of the users who are consuming those target languages. Having said that, what makes things difficult from some of the nuances are for a lot of languages, the number of words in the source language and target language differ a lot. So which means that the speech rate becomes a little bit faster or slower which gives away that, oh, it's generated by machine. What do we need to get there? Lots of data for training, and there are some ideas on algorithms as well to generate like different combinations of translations, and then pick the one which closely matches the duration of the original video, so that it practically becomes indistinguishable.
That is a very, very exciting feature. Thank you. So question for you, Jordi. What do you think are the technological breakthrough or the infra development that will be needed to enable sort of real-time translation, right? That you can really keep up with human conversation, like maybe, for example, the one that we're having right now. What would be some of the applications and benefits from those capabilities?
Yeah, no, the benefits are clear. So we could be, I could be speaking in Spanish now, and you can listen to me in English. Puedo hacerlo because I'm from Spain, but I will answer in English. So we are not far. Definitely, when we built this product, the pipeline. Now I'm talking about the backend infrastructure. We had that use case in mind. So basically, all the pieces that we built are streaming capable. So we could process. We don't need to get the whole file to start processing. So all those things, all of those technological foundations are already there. But we have to recognize that not all the models that we use, some of them are able to do real time, others not. So we need those models to improve, or those chips to be faster. So basically, to build those ML inference pieces faster to get to the real time. But we are not that far, to be honest.
That's awesome. That sounds like a huge challenge. What are some of the other media-related challenges that you experienced while building this?
Yes. So the challenges have been, we are a video team. So meaning that our team built a huge media processing system that has been powering Instagram and Facebook backends since lots of years ago. So there is a lot of knowledge and experience in those pipelines. So we wanted to inherit that. So we didn't want to create a one-off for this new AI trend. And not take advantage of all the experiences and all the knowledge that we put in those pipelines. So we work really hard to reuse our media pipelines and add an inference piece into them. So this is what we built. So basically, this has been the first challenge that we had really clear from the very beginning, that we didn't want to create this one off. And the second one, more related to the translations and dubbing product, has been the media timing. So as we saw in the video, in the presentation, there is, I think, up to 10 different AI model or AI pieces involved. So, and also much more media processing pieces involved in the whole pipeline. So being able to keep the timing, the accurate timing across all of those pieces, and not shifting more than one video frame in the audio video has been, it seems obvious, but it has been quite challenging, to be honest.
Cool, awesome. Thank you for shedding light on that. Okay, so then moving on to Liwei, I got a question for you. Can you elaborate more on the role of ML in your video pipeline? What are some of the application and use cases that have benefited from this integration? Do you think there's plans of expanding that use case?
Yes, thank you, Diana. Yeah, and thank you, organizer. Super excited to be here. So the question is about the machine learning application in our pipeline and also the future. I mean, what we are doing now and how we envision it can be expanded in the future. So first part, we have been doing machine learning in our pipeline for a long time. For example, WeMap, right? The famous WeMap, video quality metric. It's machine learning based. It uses more traditional way like support vector machine to derive the model to accurately predict the video quality, try to be as consistent as humans subject to quality as much as possible. Yeah, so that's one actual application use case. And we are doing adaptive streaming, right? We have multiple streams. They are all downsampled from original source. So downsampling quality is important to us. I think 2 years ago, we published the tech blog where we explained that how we use deep neural network to do the downsampling to get better visual results. We call it a deep downsampler. Very good name, yeah. So yes, so that's two examples of how we are using machine learning in the current pipeline. So for the future, for sure, we will continue to see how we can better or some other places to apply the machine learning for media processing. But on the other hand, I don't think that's a limitation. There can be other areas. For example, now we are doing microservice. We have these individual services, and each of them emit a lot of telemetric data. If we can effectively use this data, take actions, that will be super valuable. And I saw some other team in Netflix, they are already using machine learning to do data mining of the log data. So their alerting can be more intelligent, more robust. I personally like this idea a lot, and hopefully we can, I think that's one direction I will pitch to our team, try to do machine learning in this perspective.
That's awesome. Love that application. Cool. And then in your talk, you talked about microservice architecture and also monolithic approach. What are some of the challenges and drawbacks have you encountered with the microservice architecture that made you sort of consider going back to the monolithic approach? What were some of the sort of the pain points or trade-offs that you guys had to consider between them?
That's a very, very good question. Yes. So in my talk, I mainly talk about the good thing, right? With microservice, we are getting much better flexibility and productivity for our team. We can do production push multiple times a day, and we only need 30 minutes from code merge to production. It's really remarkable. But it's not a secret that microservice has its own challenges. Imagine that previously we only have a single app, single repo, single pipeline, single log source. But now it's broken up into multiple services. You have different repo, you have different deployment pipeline, you have different alert, log, and dashboards. And also now to get a single job done, the request needs to jump through multiple hops. So from this sense, definitely there's a complexity increase in this perspective. I wouldn't say that we want to go back to the monoliths, but definitely we also want to keep the complexity in check. So I can briefly talk about how we can make this easier, keep the complexity reasonable to manage it. We have a very good platform team. They provide a lot of toolings to make a lot of the process automatic. So there's less need to involve human. So there's less overhead for the team. In particular, one particular aspect is I talk about now, you need to correlate the activity from multiple services for a single job. So it's easier to investigate debugging. They provide tracing capabilities. So it's a very clear and also very good visualization. You can see for this particular job, what happened here, what happened here. So that's like a lifesaver, very valuable. Another thing is that microservice give you capability to do whatever you want for each service. But we figured it's valuable to establish some common conventions within the team. Because otherwise, okay, in my service, I may call this like state. You may call in your service like a workflow state. He or she may call like process state. It's just too confusing. So we figure out that, even if it's not hard requirement, but we define our own practice, like we unify the naming, terminology, and even packaging structure. So when we are switching between different services, there's much less cognitive overhead, and that saves a lot. So yes, I think that's come to my mind about. We cannot ignore that some cost of microservice and how we tackle that.
That's awesome. Yeah, thank you for sharing more on that. Our next speaker, we have Wen, and I wanted to ask a few questions about quality. So what are some of the target resolution and output format you aim to accomplish here when we're talking about scaling videos? How do these target really vary for different use cases and requirements?
Well, yeah, thanks for the question. So, as you know, that we are mostly targeting on the mobile devices for the video upscaling. And a lot of time, actually, when watching a 1080p videos versus a 4K video, actually doesn't make much difference on a mobile screen, as the screen itself actually is much smaller than like TVs or monitors. So in general, we only consider upscaling the videos to up to 720p or 1080p because these videos actually has the highest ROI for us in terms of considering both the video qualities and also the cost of running these models or upscaling algorithms on mobile devices. And in the other direction or aspect we're considering is that just upscaling the video to the video's viewport size. Because in that case, they wouldn't run into a second upscaling when we really play the videos on a player or on a screen. And yeah, that's pretty much how we consider the target resolutions.
Yeah, that's great. So then that kind of leads me to my next question is, how do you sort of strike a balance between mobile data saving and the quality improvement? Like, how do you kind of make that trade-off in optimization?
Yeah. So I think the mission of us is basically wanted to provide users the best video watching experience in our apps. So the way that we consider trade-offs here is that we wanted the users to watch the videos more or in a better experience. So we use a watch time as a goal or some other engagement metrics here to consider trade-offs. So our ABR algorithm basically is tuned based on the watch time or the engagement metrics when considering both the egress and also the data usage and also the quality and the resolution of the video.
That's awesome. Yeah, there's a lot of complexity there, right? Cool. Awesome. Thank you, Win. Going back up to Corbyn, we have a live question. So, have you ever considered taking video as input rather than just photo and text? So, rather than talking head video, we're going to take a cut of a video and then smooth out and sort of improve things to make it sort of high fidelity to the original producer.
So and this would be, I'm assuming like given a piece of video, just like improve that video to remove the ums and ands that I actually just used while I was talking right now. I'm taking that to mean, yeah, so this is something that we have thought about. We actually have something rolling out that isn't too far away from this. So yeah, something that we're thinking about. Generally, like anything that can help you tell your story is something that we're kind of all in on, and the technology in the landscape does exist to kind of make this possible. So it's something we're looking into. Something called AI Echo kind of does this already in the product today, with more features coming out over the next couple of weeks to do something similar to this, but we haven't yet got down to the ability yet to do, single word editing out. That's actually a little bit harder problem than what we have fundamentally today. So, but looking into options there. But yeah, thank you for the feedback. That was really nice.
Cool, awesome. Yeah, great answer. Next question is sort of around captions validation. This is also live, can we use the reasoning LLM models to validate the generated captions to just make sure that it matches the context?
So that's actually what we try to do today in the when we add captions to a video, we are using LLMs to do word time alignment as best as we can, using state-of-the-art models. There's definitely like the industry, I think, generally can be better here. Like it is kind of novel. It's simultaneously amazing how much can be done, but also there are clear gaps, especially when you look at like cross-language global support here. And so as we get better at this, and as our providers get better at this, we'll continue to try to stay bleeding edge.
Cool, awesome, great. So going back to Liwei, This is a live question. So can you sort of share some more insights about how would you handle the challenges of dynamic network loads in the Netflix pipeline?
Dynamic network loads, I guess maybe that refers to sometimes we got more encoding jobs, sometimes we got less. So how to make that manageable and cost effective? Yes. So we also had this is a practice we have been doing for a few years, I think as early as 2017. And also in the second page of my slides, I mentioned that we have this internal spot market. The thing is that we are a streaming company. So in the night, there's peak hour, we stream a lot of content, right? That's why we reserve a lot of instance to do streaming. But there's peak and there's valley. When there's not so many activity on this servers, they will be put into this common pool. So other team can use that. So it's like elastic resourcing. And that's where we get a lot of our computing powers because majority of the traffic are VOD, so it can wait a little bit. So that's how we do the scheduling smartly to get the most of the reserved instance and to handle the dynamic encoding traffic. So that's my answer based on my understanding of the question. But I'm happy to go to the chat channel and to elaborate, continue discussing with the audience.
Awesome. That makes a lot of sense. Another question, is there sort of like insight around validation as compared to maybe the quality side of things?
Yes, that's also a very good question. Validation is mainly to check if the stream is valid, right? If there's any bad syntax for whatever reason. We even saw some cases there's memory corruption, so just got some weird results. So this validation purpose, yeah. Quality evaluation, that's very important to Netflix. We have a few dedicated research scientists working on WeMath and the extension of WeMath. So that's why we have a separate video quality service so we can evolve that faster and to accommodate a lot of the research and development activities. Yeah. So basically, that's a rationale. We have a dedicated VQS instead of putting everything together into VBS. That's a very high level answer. So again, I'm happy to go into details with the audience in the channel.
That's awesome. Another one then, I think somebody is really, attendee is very interested in figuring out more to understand more about Netflix Cosmos-based microservice implementation. Can we get more reference and more details around that? How can they sort of do that?
Yes, yeah, I really appreciate the interest from the community. So we do have a few tech blogs, and are we going to share the slides with audience on the website? Because the last slide of my talk, we have 2 QR code. That's for the video pipeline part. But I also refer to another one which is dedicated to the platform, Cosmos platform part. Yeah. So hopefully that's enough. And I know that Cosmos platform team, they also went out to give a few talks in. Yeah, sorry, I don't remember exactly what's the venue, but I mean, if you do some search, probably you could find them.
Cool, awesome, great. Okay, I think that about wraps it up for us. So thank you everyone for all the speakers and all the attendees. We've tried our best to sort of cover all the questions live and let us know any feedback. So thank you.